Good morning. I have my Tesla switch box here, which of course is, absolutely rubbish, but whatever. So I've got these are my series. So this is one battery bank, this is the other battery bank. So now they're on, off, off. These are my parallel, so the opposite battery bank. So if this is on, then these batteries are on, parallel, and these batteries are off, parallel. That's my power on and off. I was running this LED for about 5 days, just switching the switches in the morning every day. Get a little bit dimmer and then just flip it. What I'm doing now is I thought, I can't be bothered waiting for it, so I want to see what happens. I've got the voltmeter on it, and it's putting out about 2.5 volts, and each battery inside there is a 3.7 volt battery. So when you parallel and series them, the difference should be equal. It should be about 3.7 volts, so they're not full. And I've got them running this small heater, ow, which is very hot. I can't hold on to it, but I'm just testing to see how it discharges and how. So I'm going to watch the meter, maybe let it go down to about 1 volt if it does, and then switch the switches again and watch it again, just see how much energy you can get out of this thing. Ow! Yeah, it's very hot. I can't hold it, so our next step would also be, it's tiny I know, but what could you heat up with that? Whether it just be a cup of sand or something, or just to see how it retains the heat afterwards. And also I want to just plug that into the solar panel as well. I've got a little solar panel because it's beautiful here, beautiful sunny day. It is the winter, it's getting to winter, but it's still not a cloud in the sky. Thanks very much. So I keep flipping the switch and the voltage keeps jumping back up again, and it's heating up this plate. Just in principle I'd like a bit of heating, and I thought, well, if it keeps repeating, it's reusable. Over here I have a high voltage module with a spark gap coming out one end and the other end going to the ground, which is the radiator over there. And then it's going through the pancake coils, which I don't even know if it's necessary, but I'm a bit obsessed with them. And then going into my cap dump, which has one end from the coil on the positive and one end from another ground on the negative. And that's just filling up the super cap there. Now, if this repeats itself continuously, and it looks like it is fairly much better than just using one battery anyway. You can repeatedly flip the switches and reuse the energy again and again and again. Well, if I put that box at the beginning of this system here, at the moment I'm just coming off mains, 3.2 volts, and it's, these voltage modules they put out more than 1,000 volts, don't they? So you could charge batteries. Maybe you don't even need the pancake coil, just a high voltage module, just straight out of the box basically. High voltage module, straight out of the box, charging batteries, and then flip the switch. And then, if the energy in here is running down, you can just replace it with another battery. And it doesn't seem to be running down much. I mean, once I flip that switch again, you'll see it'll jump straight back up to above 3 volts. And I actually think the lower you let it go, the higher the voltage will come back to, because you need that difference in potential. So you need them to be equal, closer to equal. So you need this to get down to 0. When that hits 0, when you flip the switch, that's going to be the biggest potential difference between the two battery banks inside there. If you don't understand what's going on, look at the What If I Did This channel, look at the previous video, understand how the batteries are attached. I can't open the box because it's so tight, and I don't trust my wiring very much, so I don't want to move the wires too much because I don't want something to come undone because I have to take the whole thing out of the box again. But basically look at the switches and then look at the Tesla switch diagram. It's heating up the plate nicely, very nice and warm, nice and warm. You're not going to cook anything with it, but the principle of it is scale it up. 12 volt batteries, light switches, wire them up, switch them, have yourself a little heater, monitor the voltage. When it drops below whatever range you want, flip the switches, reuse the heat. And then other times, just charge your battery up from the system here, charge your battery up, replace the battery in the system if it is running down, but I'm not sure it is running down even. So replace the battery in the system if you want to. It's interesting to me. Have a good day. So we've got the voltage down to 1.5 volts. And I say, because it's got the heater on it, because it's using a heating pad, it's only small, but it runs the batteries. It doesn't run the batteries. It rebalances the banks faster to do this. So I thought I'd do this because I had the like I say, I had this LED lit for days. It just wasn't nothing was happening, so I was getting a bit bored of it really. So I wanted to see if I could do it faster and see what happens. So basically, turn the power off. Voltage goes to 0. So that's the main on-off switch. Okay, and then I just turn all the other ones off. So I go parallel off, so the parallel bank is disconnected, and the series bank off, so they're not connected, no switches are on anymore. Then I just flip it, so I turn the other bank onto parallel and the other bank onto series. I've flipped it round, and then when I turn it on, boom, higher than it was last time because I let it run down further, up to 3.5 volts. And this is getting hot again, so hot you can't touch it in a minute, but I've got it on the plate, so and I'll let it run down again and we'll see what it does this time, shall we? Yeah, repeating. And like I say, if I could run it on this system and dump, I'm dumping into a cap here, I should be watching this, shouldn't I? Just dumping into a cap. If I could run it on this system, I mean, you don't need to move the voltage up much to be able to charge your battery with that. I mean, if you've got some batteries need charging. And the point is you can repeat it. So probably best with a cap dump, because the cap dump is putting in more sustained, continual high voltage, and you can repeat it. Whereas if I just attach the battery to the end of this, yeah, you're going to get up to 4 volts maybe. But I wouldn't be sure if that was actually adding anything to the system. I suppose it would be. There's a lot more tests to do. Flipping batteries. I need to build this system more solidly on a piece of wood, all connected properly, so people can see what's happening with the batteries. And then I can flip them out and monitor and check voltages and things. Here we go again. So just touching below 1 volt. It's not even, it's a little bit warm, but turn the whole system off and then flip the switches. So this one was series, so I turn these ones off, and turn the parallels off, and then I turn this other side on, series, this side on, and then this side on, parallel, all the way, make sure all the switches are good, and then we go and turn it on, boom, and we're back up again. And you see it is dropping. But that might just be a reflex from the rise. Wait for it to heat up a bit better. Like I say, I'm just testing. And this kind of rapid rebalancing of the batteries is a good way to get an idea about how viable this is as an actual power source. One more time. Down to 1 volt again. And again, so we're trying to show you more clear this time. So I turn the whole system off, drop down. This is the parallel. So this is one battery bank, this is another battery bank. So I turn off, disconnect the batteries that are in parallel. And then these are the series So these were parallel, so these were off last time. So these are on in series. The other side was series connected, so turn them off. Okay, so everything's off now. Okay, just remember what I just did. So I turn these ones off. So now I come to the other side of the battery bank and I turn these ones on in parallel. These batteries are in parallel now, and I'm going to turn these ones on in series. Boom. And I get the whole thing in. When I turn it on, oh, when I turn it on, boom. Back up again. And the question is how often can you do that, and how much energy can you get out of it, basically? How often can you repeat that process? And how much energy are you getting out of it? And does it beat just using the batteries regularly? I've got 4 batteries inside here, 4 3.7 volt batteries, and they're hooked up like that. So what I'm doing now is I'm just testing how often I can do this and whether the voltage is continuing to rise back to the original. Then I'm rebalancing the batteries by putting the difference through this small heater, which obviously runs the batteries down very quickly, but that's what I want, because I don't want to have to keep repeating this process for days and days and days running an LED. Yeah, but it's getting hot again. Whether this is going to discharge quicker than before, it looks like it's going quite quickly this time. I need a timer on it as well, don't I suppose? I need a timer, and if you were going to do it properly, you'd be using a temperature thing as well, testing the temperature as well there. What do I need? I need that program on a computer. Anyway, we'll wait for it to drop again, and I'll come back and flip the switches one more time. Once again, here we are, below 1 volt. Flip the switches, turn it off, the whole system's off, and then turn off the banks, disconnect them, off, off, on, and then turn it back on again. Bing bong, there you go. The longer I leave it, the higher it returns, because obviously the potential difference between the 2 banks, once they equalize, then it's going to reverse when you flip them. Time, I've gone even lower this time, down to 0.5 volt. So again, switch the system off, bump, turn all my switches off. So I go off, off, make sure everything's off properly, off, off, and then on, put power back on, boom. And we're cooking one more time. One more time. Here we go. 1 volt. Turn the system off. Off. Switch off the parallel bank on this side. Oh, pardon me. Boom. Switch off the series bank on this side. Boom. Everything's off. Now turn this bank to parallel, boom, boom, and this bank to the series this time, dong, dong, and then, pardon me, power on, dink, and we're going again. One more time. So I've let it go all the way down now, super low. So power off, switch off the parallel bank on this side, off, switch off the series bank on this side, boom boom, turn this series on, so connect this side in series, connect this side in parallel, and turn it back on again. Bingo bango. Here we are again, back at 1 volt, so same again, off, 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 on, reset. And we're cooking again. One more time. It's definitely depleting faster. Or what would the word be? It's rebalancing quicker. But I'll keep at it, and then at the end of all this I will test the batteries. So same as before, power off, turn off this side parallel bank, turn off this side series bank, turn on this side series bank, turn on this side parallel bank, turn on the power, bingo bango, cooking again. And this will be the last time today. I've let it drop all the way down so the two banks are equal in their value, so there's no difference in potential. Whole system off, turn off here the parallel, turn off here the series, turn on here the series, turn on here the parallel, and we go again. So it's a question of whether you think this way of using the batteries damages the batteries. Does it damage them? Does it? You're joking me. I just broke my chair. Neck. Don't make them like they used to, do they? Oh, there you go. Oh, there you go then. Does it damage the batteries to repeatedly? They're not charging them or anything, just flipping them round. What's going on here? It was messing with the pancake coil. It seems like you get more out of these batteries doing it this way around, to me. I think I've done this now about, I don't know how many times today, at least 10 times today, and it's still producing heat. It's still hot. And I suspect that when I open that box, and I'll just show you the box, let's have a look inside. What a fucking mess, eh? Pardon me, French. Not so messy, but 4 batteries and all the switches inside. It's a question of whether you think just using each battery one at a time, whether they would sustain a continual output for longer than this way, where I've recycled the output at least 10 times. But it's definitely going down slower. I mean faster, sorry. It's definitely dropping a lot quicker. Going on with my my cap dump here. I think probably my tip 31's probably overheating. When I touch it, it cools down again. It gets back. It's happy again. Gotta hold its hand. Which is never a good thing to be in a circuit, is it? When you realise you holding it is going to make it happier. I'm just practicing a little bit of Dual Thieves, pancake coil dumping, resonating with the earth, all that sort of stuff over this side, but yeah, over there, still making heat. I mean, I suppose the ultimate test would be super caps in the box, using the cap dump system here to charge a super cap, and then seeing how the super cap values all add up at the end of it, and see if you can actually get more out because of the way you're using the batteries, because the way the charges behave is differently when you're, I don't know how to say it, using them backwards or just using them non-conventionally as people have been taught. But I'm experimenting anyway.